All right, this little discussion is going to be about what I consider to be evidence supporting particle theory instead of the duality theory of photons. I say it's strictly a particle, and it's just spinning in a spiral vortex that's cascading through space so fast that the little spinning particles go through these tiny little slots, and you can see them in a pattern that is exactly expected in my mind. Now, think of it this way. This is like what I'm considering to be the vortex. I mean, obviously this is the galaxy, but it's a similar idea. When the particles that I'm talking about go cascading out from whatever they're emitted from, they come out in trillions. They don't come out one or two or three or a little tiny bit. They come out at trillions of them at a time. Boof! And it's just continuous. The surface is covered by trillions and trillions and trillions, and they are completely emitting something because they're being bombarded by something that can't be stored completely. So they're going to emit something. If it's white, it's going to emit a lot of stuff. Now, this is my point, and you'll see what I'm going to say in my videos. And the first thing I'm going to do is I'm going to talk about how there's proof that atoms are these are particles. They're not waves, and they're not dual. They're particles. I'm going to tell you that, and I guarantee that's, well, I'm going to have you decide what you think. Now, I'm also going to tell you that moving electrons in space or through wires create magnetic fields around them that spin in a specific manner. It's called the right-hand rule, and I'll show you that. All of these things are observed, and all these things are fully understood, and it's like a screwing through a plate affair. And my model takes into account single plate, single slot, works perfectly, double slot, perfectly, and there's a bunch of other experiments you could come up with that would really lock it down, but everything observed appears to be correct. Now, this is right off of Wikipedia. It's a Crookes radiometer, and you see what's happening there? That's because light's hitting that. If the light didn't hit that, it won't spin. So I'm saying light consists of particles. Case closed. All right, all the physicists and so forth are going to be screaming, oh, they're electromagnetic waves. I'm not saying they're not. I'm saying they're particles, I can tell you that, and I know that for a fact because they hit things and move things. And only something that has mass can do that, and that's, to me, a particle. So, as far as I'm concerned, I'm going to show you why I say that in a second. But, in addition to that, I am saying, electrons, or negative charge particles, whatever you want to call them. And when they leave, they spin because all electric charges running in a direction create a field around it, and it's a spiral field, and it's called the right-hand effect, and right-hand rule. And if you put your hand this way and it's going that way, they wrap around this way and they pulsate down. And you can look all this stuff up, because I'm not making anything up. And you can see, here it is right here. There's the right-hand rule. And this is from a place called physicsed.buffalostate.edu. And it's not unknown. It's fully understood. And these are these little spirals. Now, depending upon how much intense force there is, these can get bigger and bigger and bigger. And they actually put on what we used to call choke coils on here to keep those big electromagnetic interference from causing trouble with CRTs and all that business. CRTs were cathode ray tubes, and I'm going to show that in a minute, because those affect how these think. Oh, if I put a field here, I can push that way. If I put a field, I push it that way. And that is what we also see with these light emission radiations. All right, I'm not making anything up here. Here's what happens. In here, they generate, excite electrons. And here you see electron beam, swish. It's not going to go straight. Well, it could go straight, but we've got it going through deflecting coils. And we can push it that way or push it this way. And that's how they used to sweep across the screen to make the colors show up. Well, actually make the images show up on the old cathode ray tubes. They would light up phosphors. All right, this was a post on Facebook by a fellow named Peter Cullinane. Absolutely fabulous. And he's got a bunch of different graphics here. Very, very nice. And it stimulated a little thought. Now, this is our solar system that's moving through space very quickly, and everything is spiraling behind our sun. This is what is being said here. Now this is a side view, same thing, Peter Cullinane, and he's given me permission to show these things. And this is a side view of this. And as it goes through space, you can see what happens. Now, it is a vortex, and I'm saying that the distances between these circles are the potentials of the particles that are following behind, and the frequencies are the durations of these waves. Now think about this: when it hits a plate, it's going to screw itself through. So the particle, if it hits the slot, it'll go through. If it doesn't, it won't. And I'm going to show this in the double slit experiment. But this shows quantum effects. It shows screwing in from this direction. If it goes around the outside, it's screwing from this direction. That gives us the double slit, multiple images. It accounts for everything that I can see. All right, here's something you have to look at really careful. It's on Wikipedia, but look at these patterns. And this talks about the dots, and it's literally like a dot matrix printer. In the double slit experiment, they build up over the course of time, and it doesn't take long, but it happens fairly quickly. But here's something I want you to notice. I'm talking about circular patterns swirling all over the place. Look at this. Look. Tick, 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 tick. Tick, 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 tick. There's like a circular pattern there. There's like a circular pattern here. Okay, there's all over these things that look like they could be associated together in circular looking arrays. And as they begin to build, this is the patterns that they build up. And this is quite obvious because there's a slot here and a slot here. And as it comes through, it's spinning like crazy. Now if it hits as it's spinning this way, it goes that way. If it hits as it's spinning this way, it goes that way through the slot. It's just obvious going to happen. And some of them are up here, some are down here. Some of them are big. So they may only hit once in a while. One little click here and one little click there. And that's why they fade out as they go further and further away. It's just the way it works. To me, it's totally expected. All right, this guy is fabulous. It's on the internet, and it's a Veritasium. On YouTube, and this is the original double slit experiment. He took a box, and you can't really see it, but there's two tiny lines, one right next to each other, and this is what separates the light. And I'm saying things are coming spinning at this, spinning like this, and as they hit, it goes this way if it's spinning, and the particle hits on this part of the rotation. And if the particle hits on this part of the rotation, it goes that way. Simple as that. And there's the closest ones, and there's always, you use the right-hand rule. So the field goes this way if it's going this way. It's propagated this way, and it's closer, closer, closer. So it's like spinning, spinning, spinning. And, you know, that is a known rule in electronics. And as these spin through here, on the back plate, it spins going this way, or it spins going that way. Depends on, you know, it's at the top or the bottom of the spin cycle, so to speak. And then it makes these patterns. And depending upon how far away the back plate is, you get more and more bumps. If it's very close, you're just going to go rit, bang and hit it. Rit, bang and hit it. You know what I mean? You know, bang and go in there and hit it. And if it was coming this direction, it would be here, bang and hit it. Of course, they're going to be coming from way down here. They're going to be coming from up over here. They're going to be coming from here. That's what gives you that bar across. Now, That separates them. Now, the further back you go, you can create, it will go here and further back and further back. So you might get 1, 2, 3, 4, 5, 6. You can get a whole batch of bumps going backwards, because it depends on how far back you are from this double slit. And he shows you this as he goes through this. It's very interesting. I'm going to just go ahead and play. Now he's asking people what they think.
We need to tilt it towards the sun a little bit, so we want the sun to hit.
I hope it's all right with this guy. If it's a problem,
what are we going to see
he's got to
the
tell
The
us.
obvious thing you think you're going to see is you're going to see two lines.
2 lines on the bottom of the box.
Everybody
Two
thinks
bands.
so.
2 little
I
lines.
think
Yeah, I think it'll be one line instead of 2.
I could expect to see the whole box lit up.
It'll probably be a kaleidoscope of some sort.
A bunch of colors.
Probably, yeah.
Rainbow, different colours.
There, have a look. You expected to see kind of one line. Is that what you see?
No.
I see dots.
How many?
It's one circle.
Well, there's one in the middle strongest, 2 either side.
The 2 on the outside are multicolored, and the one in the middle is just white.
Listen
Out of a
carefully.
rainbow.
The rainbow of colour as well.
Quite a few colours, but lots of little dots.
Like there are more dots appearing.
I think I can even see more dots spreading along.
You hear this?
Yeah, that's amazing. Yeah, I can see tons of dots now. Not tons, but I can see dots spreading.
It's because
How's that?
more and more
Yeah, definitely.
are getting through.
Amazing.
Yeah, that's incredible. And that's just nothing else apart from
2 slits.
2 slits.
Okay, that blew that guy's mind. Okay, once again on the internet, it's Science 122, Program 27, Electrical Connection. It's right on the images, and I'm not stealing anything from any of them. I'm just trying to prove a point. Now, these are the energy levels of things, and I agree with this 100%. Look at this hydrogen. Look at how powerful that is out there. Look at magnesium. Look at how powerful that is out there. And these are fully understood. When you see these things burn, you can't even look at them. And I'll show you that in a second. But these tell you all the different molecular or atomic states of these different types of materials, and they isolate them off. So you're only looking straight through calcium or magnesium or neon and so forth, and you get these kind of patterns in there, and that means they're absorbing, for whatever reason, they're absorbing those wavelengths. All right, here's something else I've been following. It's not part of this, but it plays into it because we're talking about atomic forces. And this is where I discovered about shock values, hydrogen explosiveness and everything. This is a sinkhole, and so there's one up here during a mountain collapse, volcanic collapse. Now watch this. This is scary. Watch these things go shooting off to the sides and things. This is hydrogen that's burning, and it burns at an incredible rate. And these sinkholes are filled with this kind of gas. Boom, here it goes. It's getting ready to burn out. You see the one that's on the top and the one that's on the bottom? They will consume all their hydrogen before they go out. And when they go out like somebody just pulled. Watch this. Bam! You see that? Look at those pulses and that stuff that's shooting off to the side. That is what's known as shock. And those shooting up beams of light into the and then there's another thing that's called focused shock, where it's focused up through the earth, through these sinkholes, which are everywhere, and they're completely tubular sinkholes, and they shoot out these photon pulses when that collapses. Anyway, that's a whole another issue, but it's got to do with energies. And it's exactly what we see in the single slit and the double slit experiments. Exactly what we see.